All right, everybody. This is the last video on calculating the volume of something. Today we're going to work on calculating the volume of spheres. If you do hear some background music, my youngest daughter is in there practicing her clarinet right now. So whether good or bad, you may, if you listen closely, hear some tooting. And if that's the case, then, then now you know what it sounds like when you're practicing clarinet. So with that in mind, let's go ahead and calculate the volume of some spheres. Spheres with this really poorly drawn sketch are really just like basketballs or baseballs or softballs. Spheres are any round, object, right? Three-dimensional object. And in a sphere, what's kind of cool about spheres, if I can draw one, that's not too bad. If I could draw a sphere, normally the way I would tell it apart from a two-dimensional shape, right? 2D circle would have a radius. Or if I went the whole way through, it might have a diameter. And I say it may, I shouldn't say that. It does have a radius and it does have a diameter. 2 dimensions means it goes in 2 directions. It goes left and right and it goes up and down. But if I try and take this, let's see if I can draw 2 circles that are kind of circle-like. That's not too bad. All right. So if I want to make it 3D, if I want to make it look like it has left and right, up and down, and kind of in and out, what I'll usually do is I'll kind of visually mark the center with my eye and mark a spot to the left and to the right. And as best as I can, I'll draw a little arc this way and then an equal arc the other, usually dash, but it doesn't have to be. And that's supposed to make it look three-dimensional. You might have to use your imagination a little bit, but you get the idea. What is kind of cool though is that the radius is still the radius. I don't want to clutter this up too much, so I'm going to put the word off to the side. And this could still have a diameter. The diameter would normally be drawn from one corner to the other. So if you imagine it going the whole way across, then that red one would be the diameter, right? So spheres have radii or a radius, and they have a diameter as well. So let's get to it. Let's calculate the volume of one of these. And the truth is we're only going to do one. You can rewatch the video if you need to see it again, but they all work the same. They're all based off of the same formula. Whereas this is a 2D model, so we're really not going to be focused on the 2D model at all. We're really only going to be focused on the 3D. Let's see if I can, let's see if I can just cover this up so we're not even going to worry about it. There we go. And now let's pretend that's not even there. Let's only focus on the three-dimensional piece. And the volume of a sphere can be done the same way we did it before. It could be an approximate or an exact answer, but it's always going to be the same thing. It's going to be 4/3 pi r cubed. And that's it. Because there's no height in these. Oh, well, there's a height. It goes from here down to the bottom, but the height down to the bottom is, it's based on the radius. You could probably argue it's the diameter, right? So let's go ahead and use this formula, which once again will be on your formula sheet. Let's create an example and be on our way. So let's call this shape, 1, 2, 3. Let's go ahead and say that this thing is 3 centimeters. Let's call the radius 3 centimeters. We could have also done the red one and said the diameter was 6 centimeters. It would have been the same thing. All right, so let's calculate. There's that clarinet. Let's go with the exact first. Okay, so here we go. 4/3. Now it's pi, so we're going to use pi. Radius cubed, and radius is 3, so it's 3 cubed. So let's see. 4/3 times pi times 3 times 3 times 3 is 27. And I am going to go ahead and show you some cool canceling here. I happen to know that 3 divides 3 once, but 3 divides the 27 9 times. So I get some cool canceling going on. When that happens, all I have left on the top is the 4, the pi, and the 9. 4 times 9 is 36. Pi is right next to it, and I'm a little bit out of space, so I'm going to put centimeters cubed, kind of small down to the side. But there is my exact volume of a circle. It's 4/3 pi r cubed. I cubed it. I got lucky with some canceling. If you don't get lucky with the canceling, it's not a big deal. You're probably going to grab a calculator. You're going to multiply the top number, in this case 4, always 4, times whatever you got in this value. In my example, it was 27. So 4 times 27, you would get an answer, what would it be, 80, 90? It would be 108. And then we would take 108 and divide it by 3. So you could do that every single time. 4 times 27 divided by 3, or 4 times whatever your number is divided by 3, and that'll give you the first number here. Sometimes it'll have a bunch of decimals, sometimes it won't. Let's hope it doesn't. If it does, then you're not probably going to be all that exact. You're probably going to be approximate. And speaking of approximate, squiggly line like we did before is now simply going to be 36 times pi. And I'll go ahead and do this one. I sometimes skip this work. Ooh, yikes, I wrote this upside down. So let's go ahead and write it the way we learned it when we were younger, with the number with more digits on the top and the number with less digits on the bottom. That'll just keep our thinking straight. This is 24. This is an 8 and 18. 3 times 4 is 12. Carry the 1. 4 and 9 and add them together. 4, 0, 3. Carry the 1 and 11. 2 decimals, so I move it 2 decimal places over and I get 113.04. So I'm going to say it's approximately 113.04 centimeters cubed. And that's it. You can, of course, watch the video more times if you need to, but the concept is straightforward. It's one formula. I'm going to have to give you, or the problem will have to give you, the radius or the diameter. If they give you a diameter, just cut it in half and find a radius. If they give you the radius, excellent. Put it in, cube it. Use your calculator with the 4 and whatever your number is cubed, divided by 3. That'll be your first value. And then for your exact, keep the pi. For your approximate, multiply it by 3.14, and you're done.